pretty much my love life is in the toilet. All right. So polar and rectangular, we got to convert back and forth between the two. And we alluded to this last time. Here are this is your XY Cartesian plane. Is that correct?
That's what I usually call it.
Yeah, me too. And then, or it's a rectangular because these are all rectangles, and then these are your polar ones. So we want to be able to convert back and forth, be able to plot things in multiple spots. So, all right, I would take a moment and write these down on your color sheet or whatever. What do you on your notes sheet?
In their notes, yeah. Write it in your notes. Yeah.
Yep. These are going to convert from polar to rectangular. This side's polar to rectangular, and this is the opposite. They're going to give you some rectangular coordinates, and you want to convert them to polar coordinates.
Yeah, and if you flip back a couple pages in your notes, you'll probably notice that these are very similar to the vector equations we gave when we were converting from direction angles to components.
Look at you. You're on the ball today. Just kind of a side note here. This angle must be in radians. Must be in radians for these to work. Must be in radians. Radians, radians, radians. Okay, so let's try a couple of examples. We want to convert from polar here, and we want to convert it to rectangular. So this is R, and this is theta. Color is kind of hard to see. Sorry about that. So if I want to figure out what x is, I'm going to go x is equal to R, which is 3, times the cosine of theta, 5 pi over 6. So just kind of as a review, how do we find the cosine of 5 pi over 6? I'm a big degrees guy. I think better in degrees. Right. So I would probably take the 5 pi over 6 and multiply by 180 over pi, and I'd get 150 degrees. So 150 degrees. What's the reference angle for 150?
It should be 30 degrees.
30 degrees. Okay, so essentially, I'm taking, all students take calculus, I'm taking the cosine of 30. What's the cosine of 30? You remember?
Oh, I always go back to that triangle.
Me too. I always go back to, wow. Wow. Maybe not that triangle. That was really bad. All right, here's my 30. 1, 2, 3 square rooted. So the cosine of 30 is going to be square root of 3 over 2. And it's going to be negative.
It's in the second
right.
part.
So x is equal to 3 times the square root of 3 over 2 negative. So negative 3 square root of 3 over 2 is the x part. What was it? Negative 3 square root of 3 over 2? You going to remember that?
Yep, negative 3 square root of 3 over 2.
All right, so.
it's going. Negative 3.
Negative 3 square root of 3 over 2, comma. We need to figure out what the y coordinate is. So we're going to do the same thing with y.
Right.
So y equals r, which is 3. This time we're doing a sine of 5 pi over 6. So I believe the sine was 1/2.
Yep.
Looking back at that triangle. And is it positive or negative? Positive.
Positive.
Positive. Okay, so the answer is going to be 3 times the sine of 5 pi over 6 is positive 1/2. So the answer is 3/2. 3/2. And a lot of my students want to change that to 1.5. I always leave it 3/2.
Yeah, leave it as a fraction. They're your friends.
And I'm a little tired.
Okay, let's look at Q. Once again, this is our R, right? And now this is negative 200 degrees. But we said for these equations, don't we have to be in radians?
Yes.
Okay, and negative 200 isn't kind of a nice angle that we know how to find the cosine or sine of kind of readily. So let's convert this to radians. So negative 200 times pi over 180 equals something. All right, so should we use the calculator to figure this out?
Do you want me to? Okay. Sure. All right, clear. So what do you want? Negative 200 times
Pi over 180.
Pi divided by 180, and we're just going to leave it as an ugly number because it's not one we're used to.
That's not one.
Negative 3.49. Can you
Alright,
agree with that?
Yep.
Negative 3.49.
So this is, oh,
You need your pen there.
yeah. Negative 3.49. Okay. Alright, so if we want to go find the x and y coordinates, we're just going to go x equals the radius, which was 2, times the cosine of 3.49.
Negative 3.49.
Oh, thank you.
Mm-hmm.
Negative 3.49. And y equals 2 times the cosine.
Oops, sign.
Oh, sign.
Sign.
Oh, no.
You're on a roll.
Oh, that's a good eraser.
Your friends call you butter.
I don't know what that means. So,
I got an idea. Isn't that okay?
good.
You were kind of having a day there.
Yeah,
All right,
sorry.
would you get me back to my arrow here and we'll
Yeah,
punch
yeah,
this in the calculator?
There you go.
All right, now I remember this had to be, their angle had to be in radians, so let's double check our mode just to make sure.
Oh, good thing we checked.
Yeah, we were not in radians. So boom, now we are. Oh, the excitement. All right, so we would like to go 2 times the cosine, what was it, negative 3.49?
Yep.
All right, so there's, was that x?
Yep.
All right, and we'll go 2 times the sine of negative 3.49.
That was the second.
Oh, swear a lot. All right.
Pretty close.
2 is the sine negative 3.49.
Bingo.
All right, so what are the coordinates here?
So finally our coordinates then, thank you for kicking the pen on my, our coordinates here then are going to be negative 1.87.
8, 8. Be careful, be careful.
88 and 0.68.
Man, that looks really bad.
Yeah,
doesn't it?
yeah.
Might have to watch that one again. Sorry about that. All right. Sorry to get right in your face
That's
there.
okay.
Boom. So we want to go backwards this time. So we want to. Why don't you take the I'll take the top and you take the bottom. Is that okay?
Okay.
All right. So this time we want to convert to polar. And then, so this is your x, and this is your y. And I want to figure out what r is. So r squared equals x squared, negative 1 squared, plus y squared, which is 1 squared. So this is 1 plus 1 is 2.
Yes.
I want to take the square root. So r equals the square root of 2. I did my half.
Cool. All right, and then we want to go find theta, right? Because we graph r comma theta. So we have this equation that says tangent of theta equals y over x. So that's 1 over negative 1, which is just negative 1. All right, so I want to know what is my theta when the tangent is negative 1. I think, if we remember this, all students take calculus. Tangent's going to be negative over here, and the question is, what is the angle? I think, isn't that 3 pi over 4?
Yes.
3 pi over 4, so theta equals 3 pi over 4.
Right. And we're going to have a few students that get really nitpicky and say, no, wait a minute, guys. You told me anytime I take the square root of a variable, I should have a plus or a minus. Well, the plus would go with this angle, and the minus would go with this angle. If you look for where both places where tangent is negative, I always just use the first one. Just use the positive one and use the first angle you come to.
Yep.
All right, thanks for taking our class.